Chia, can you read us the essential question, please? Can you read us the essential question?
How do you find the trig function at any angle?
Perfect. All right. You can you read us the I can't statement, please?
I can find the rounds of a trig function given the value of 1 to.
Good. All right. So we're gonna continue that today with a slightly different look at it. We're also going to talk about how to get back to the angles a little bit. You do need your unit circles out. So dig your unit circle out. Get it out in front of you. Hopefully you have the one with the coordinates on it. That's the one we want. Well, you're doing that, actually, I'm going to grab mine off of another page here because I know I'm going to need it in a few minutes. I want it for this guy right here. Okay. So what I'm going to do is we're going to skip all the way to example 16. Okay. We're going to skip over the reference angle stuff. The way we do it covers what's there. Kind of already talked calculator. I think there was ones with quadrant angles. We've already done all that. So we're not going to waste time. We're just going to go ahead and skip all the way. And this is the same as using our unit circle to find it, which we've talked about. So let's just go to example 16 because it has a slightly different take on things that we've been talking about. Okay. All right. Where is it? There it is. Okay. So it's telling me, and there's a couple of ways that I could do this. I'm going to choose to use the triangles like we did yesterday. I could use my unit circle on this one, but let's talk triangles. Okay. So we're going to find the indicated trigonometric value at this in the specified quadrant. We touched on this yesterday. So the first thing I would probably do for myself is I'd probably draw myself a nice little XY axis. Okay. And what quadrant do they want my triangle in? Quadrant 2. So I'm going over here and I'm going to draw a triangle in quadrant 2. There's my theta. Okay. Then we're going to talk about sine. In SOHCAHTOA world, what is sine? Good. So this is going to be my opposite, and that's going to be my hypotenuse. So my opposite is 1. My hypotenuse is 2. Okay. All right. How do I get my third side? Pythagorean theorem. Okay, so I'm going to do my Pythagorean theorem. I'm going to go 1 squared plus, I don't know what it is, so I'm going to call it, it's in the x direction, so I'm going to call it x squared equals 2 squared. What's 1 squared? Good. What's 2 squared? 4. How do I get the 1 to the other side? Subtract. What's 1 to minus? It's 4 minus 1. 3. Take the square root, technically plus minus, right? In this case, did I go in the positive direction with the x or the negative? Negative. So I'm going to make it negative square root of 3. Okay. So this is going to be negative square root of 3. All right. What they're asking me to find is the cosine of that triangle. So the cosine of theta equals, cosine is what in the SOHCAHTOA world? Good. So what is on my adjacent? And what's on the hypotenuse? 2. Okay. It's just a different way to find it. Okay. All right. Let's take a look at example 17. Okay. So again, I'm going to draw my picture. Okay. What quadrant is my triangle in this time? 3. Drawing it down here. Okay. All right. We're talking about the cosecant. So cosecant is what in SOHCAHTOA world? Good. Hypotenuse over opposite. Is hypotenuse ever allowed to be negative? No. So I know that my hypotenuse is going to be positive 13 and my opposite is going to be negative 5. All right. I do need to find the other leg because I do need adjacent to find tangent. So how do I find the other leg? Or does anybody know what the other leg is without doing it? 12, right? Because it is a Pythagorean triple. However, okay, so if I didn't know that, I would use Pythagorean theorem just like I did in example 16. Okay. We're going to the left, so should it just be 12? Yeah, because we went in the negative direction, we're going to make it negative 12. Okay, and again, if you need to do negative 5 squared plus x squared equals 13 squared, you totally can. Okay. All right, what's tangent in SOHCAHTOA world? Good. What's on my opposite leg right now? Negative 5. What's on the adjacent? What happens with the double negative, everybody? Cancel to positive. So does that make sense? Quadrant 3 and we got tangent positive. That's something that if we looked at the orange ring of our unit circle, we would know is a true thing, right? That tangent is always positive in quadrant 3. Okay. We're going to start this one together, and then I'm going to have you do a little bit of it on your own. Okay. So go ahead and read the instructions to yourself. All right, we did start something like this yesterday. We need to figure out what quadrant that is in, and then we will deal with the six. Actually, I could do one of them right now, couldn't I? Technically, what's always in the denominator no matter what? 1. So if cotangent is negative 5 over 1, which one do I get for free? Tangent, right? I get to do the reciprocal, so I know that tangent is negative 1 over 5 or 1 over negative 5. Okay, so now let's talk our circle, right? We've got, I use my all students take calculus abbreviation. What sign is cotangent? Positive or negative? I want to hear from everybody. What sign is cotangent? Okay, I have 2 people now. What sign is cotangent, everybody? Negative. Okay, so negative, if it's negative, what quadrants is cotangent negative in? Okay, 2 and 3, not 2 and 3. 2 and 4, right? 3 cotangent's positive, so 2 and 3. All right, and then what does this mean when we're greater than 0? What sign? We're positive. Okay, so what quadrant out of these 2 is sign positive in? 2. So I know that my triangle has to be in quadrant 2. Okay. It doesn't matter if we do tangent or cotangent. So we've got tangent there. What is the tangent ratio in SOHCAHTOA? What over what? Opposite over adjacent. So my opposite is 1. My adjacent is 5. Which one should be negative? Good. 5 went in the negative direction. All right. How do I get my hypotenuse? What am I going to have to use? Good. So we're going to go 1 squared plus negative 5 squared equals, I don't know. We'll go with r squared because it's on the radius. Doesn't matter. Pick your favorite letter. All right. What's 1 squared? 1. What's negative 5 squared? 25 equals r squared. So what's 1 plus 25? 26. Take the square root. Is the radius or the hypotenuse here ever negative? No. So it's square root of 26. All right. The instructions said we had to find the remaining trig functions. We've got 2. We need 4 more, right? So I'm going to give you a minute or so. I want you to find the other 4. You should, now that we've done all that setup, you should be able to find the other 4. So everybody take a minute or 2 and try it on your own. Give you about 30 more seconds, as far as you can in 30 seconds. Okay, go ahead and check it with your table. Okay, let's check it together. Make sure we're all on the same page. So, what is the sign before you rationalize? What'd you get? 1 over square root of 26. If it was me, I would immediately flip that for cosecant, right? Do I need the 1 in the denominator? No, you could just write square root of 26, okay? If this was like a matching thing or something on a quiz, it'd probably just say square root of 26, okay? I'd rationalize this. We get square root of 26 over 26. Very good. All right. What about the cosine before any rational? Oh, I guess you see cosine. Yeah, before you rationalize, what do we get? Good. I would go ahead and flip it for secant. Doesn't matter where the negative goes. And then rationalize. So negative 5 square root of 26. That's a 26. No, you can't read it. Negative 5 square root of 26 over 26. Okay. All right. We're going to really quick review this. We're going to put this in the calculator. So open up Desmos. Just to make sure we've got this down. Open up Desmos. This one. Okay. I'm going back and look at it here for a second. So it says use the calculator to evaluate the trigonometric function. Make sure your calculator's in the correct mode. If there's a degrees on it, it should be in degree mode. If there's no degrees on it, it should be in radian mode. So this one that says -7 should be in radian mode because there's no degree symbol. If there's a pi, it should definitely be in radian mode. So we're going to do cotangent of 410. And we're going to practice this a couple of different ways because it came up weird in other places. Let me go back here. So cotangent of 410. And then we want to make sure you come over here to settings. And we're using this version of Desmos. It starts in radian. So I'm going to flip it to degrees. Okay. So I would be writing down 0.839. We learned on our quiz the other day that Desmos embedded in Otis doesn't like cotangent for some reason. Okay. So the other way to do it is the reciprocal. What's the reciprocal of cotangent? Tangent. Good. And so we would do 1 over tangent of 410 and we would get the exact same thing. You used to, in like the old calculators that I used growing up in high school, okay, you had to do it this way. All right. They weren't as sophisticated. They didn't have all 6 trig functions on it. You had to know. In fact, even when I started teaching like 20 years ago, we still had to do it this way. Okay. The calculators hadn't caught up yet. All right. So we're going to put 0.839. Okay. So 0.839. All right. We're going to do sine of -7. Let's try that one. All right, so I'm going to type in sine. I'm going to type in -7. I'm going to double check my little settings guy over here with the wrench. I need to put it into radians. So I should have -0.657. I'm going 3 decimal places. 0.657. All right, everybody on your own, put in example 21. You can do P, start typing PI, pi will pop up. Is it over 9? Yeah. All right, 1.064. Everybody good? All right, 1.064. Perfect. All right. Scroll to the next part. If you don't have your unit circle out, you need it for this part. Read the instructions to yourself for me. Okay, we're going to take a baby step into this. This is probably one of the more important things we need to understand is reversing the unit circle. Okay. Won't be hope maybe I can even I will see if I can come up with a game kit for this one too, because this is really something that we should have on there. We're supposed to find two solutions to the equation, give your answer in both degrees and in radians, which we're going to read right off of our unit circle. Okay. So is cosine the x value or the y value on our unit circle? It's the x value. So what that means is what they want me to do is they want me to find theta. They want me to find the angle. This is the x value. So I need to go everywhere on my unit circle where the x value is positive square root of 2 over 2, and I'm going to read the angle. So I'm going to look around my unit circle. All right, so I'm traveling around my unit circle. Oh, look, there's one of them. So the first radian measure I'm going to write down is pi over 4. What is that in degrees? You have it on your unit circle. I don't have it on my version. 45. Good. Okay. Now, there's going to be at least two places where this happens. So I'm going to keep going. Okay. I'm looking at all of my x values. I'm running around my units. I still don't see a positive one. There's a negative one. Up right here, I've got another positive one. So what radian measure am I going to read for that? It died. And this flashed too. That's always good. Okay. Thank you. I will say that all again in just a second. Let me get it back up there. Maybe. Connect. Not yet. There it goes. All right. Pin is going to be 5 zeros. 5. Enter. Connect. It's not quite as bad as last year when, you didn't share your screen and you went 10 minutes of teaching without sharing your screen because you didn't notice the chat. Them yelling at you to share your screen. Okay, did we get the first one? We got the first one, right? Okay, so let me start from the second one. So I was here, right? I'm going to keep looking around my entire unit circle, right? And I'm looking at that x value, and I'm kind of traveling around you don't have to draw this on there. I'm just trying to show you the path I'm going. I see it right there again. So what radian measure is that one at? 7 pi over 4. What's the degrees right there? 315. Okay. Not a lot of written work, but a lot of brain work, right? There's a lot of work that we're going through and looking at the unit circle. Okay. All right. Look at example 23. Okay. Is cosine the x value or the y value? X value again. Okay. So we're doing doing two x value examples. This time, though, I want the x value to be negative square root of 2 over 2. So I want you to try that one. Go all the way around your unit circle. Anytime you see negative square root of 2 over 2, write down what the radian and degree measure is. There should be two places for both of them. 2 places. See if you can find them. Okay, check them with your neighbor. I should hear some discussion. Check them with your table. Can I go to the bathroom? Yeah, I need to see your ID. All right. Double check what I highlighted. See if you agree with it. It's not the calculator that I need to send you to the bathroom. So. Okay, there you go. All right. Do we agree with 3 pi over 4? Okay, what'd you get for the degrees? 135. Good. All right, what about 5 pi over 4? And then this one here is 225. Everybody good? Okay. You'll notice that 24 and 25 are going to be a little bit different than that because it's not a sine or a cosine. Sine and cosine is nice. We can read it right off of there, right? For the other ones, I have a little bit more work I have to deal with, okay? So first things first, what's the always denominator? What denominator do I always get? 1, okay? What is cosecant the reciprocal of? Sine. So couldn't I flip the sign on that? So sine of theta equals 1/2. Same thing with secant. If I had secant, I would flip it and make it cosine. Okay. All right. Is sine the x value or the y value? So this time I'm going to go around my circle and I'm going to find everywhere where my y value is positive 1/2. All right. I want you to take a stab at that first. So go look around your entire unit circle. This time you're looking for where the y value is 1/2. Write down your degrees and your radians, please. Just positive because it says positive. The negative positive ones, they're coming in about a week. Okay, check it with your table. Check with somebody at your table, see if you guys match. All right, do we agree with where I highlighted? Pi over 6, 5 pi over 6? Yeah? Okay, so that would be pi over 6, 5 pi over 6, not 60, 30, and 150? Okay. Cotangent, so secant and cosecant, not so bad. Cotangent and tangent are a little bit uglier, okay? So kind of bear with me. I'm going to explain to you how I think through this, okay? And I'm going to use some of the patterns that I know about in the unit circle to explain this, okay? First of all, what is my always denominator? 1. Okay, so I know I've got that, okay? I know that cotangent is the cosine divided by the sine, right? That's one of the things we've learned in the last week, okay? On my unit circle, what is every single thing divided by? 2. So basically, I would have reduced this if I was working it kind of from the front, right? If I started with whatever sine cotangent of 5 pi over 4, I would reduce that. So I'm going to unreduce it. Okay, I'm going to add in my square roots of 2. So I know this is the same as saying negative square root of 3 over 2 over 1 over 2. Okay. What that means is the coordinate I'm looking for, this would be the x part of the coordinate, this would be the y part of the coordinate for sine, cosine, and sine, is negative square root of 3 over 2, 1/2. So I'm looking for that one. But does my negative sign have to be in the top? Did I have to put the negative here? Could it have been down at the bottom? Yeah, so the other coordinate I am looking for is square root of 3 over 2, negative 1/2. So I need both of those coordinates in order to find this one. Okay, so I want you to look around your unit circle. Don't call them out yet. Just write them down on your page when you think you found them. Okay, so I'm looking for those 2 specific coordinates. Let's see what you can find. I'll give you a minute. Look around your unit circle, find them. All right, where was the first one? What radian measure? 5 pi over 6 is the first one. Where's the second one? 7? 7 is negative, negative. Did we want negative, negative? No, so keep looking. Where's the next one? We're square. There you go. 11 pi over 6 has one positive, one negative. Okay, we see the difference in what you told me and what we have. Okay. All right, so we want to write down 5 pi over 6, pi over 6, 11 pi over 6, and it was what? 150, 330? Okay. All right. We're going to continue working with that piece because that piece, we keep building on it. That piece will come back in next year. Okay, when we do have to be able to solve equations with this. Okay. All right. So here's the deal. I want to see everybody working on one of the assignments for this week. Okay. If we're working on one of the assignments for this week, we can bring out Fishtopia for a little bit at the end. Okay. So there's a Delta math that I assigned yesterday, and then there's a worksheet that matches what we did today. So I want you to pick one of the two if you haven't worked on it yet, okay? And start working on it right now, okay? You need practice for this because look at what I put on there. I put learning quiz on Thursday. I'm not going to teach anything else new this week, okay? Because I know a lot of us have an AP test at the end of the week, right? So I want you to study for your AP test, all right? But we're going to we'll review. Tomorrow will be just about reviewing class. Thursday will be about taking the quiz, and we'll do something else. Okay. I might start setting you up a little bit for what we're going to do next week. That's hands-on. Next week, I will not be in class on Tuesday and Wednesday because I'm proctoring the AP tests those days. Okay. But I'm going to give you an assignment. Hopefully that's a little bit hands-on one of the days. So maybe we'll start setting that up on Thursday. Okay. All right. What's wrong? I am proctoring Lang, which I almost always proctor Lang, and then I'm proctoring helping out with AP Spanish. Yeah. Yeah. So I will be there. I push the button on the CD. That's my job. So I let him do the talking. So because I do the talking for Lang. So all right. I want to see everybody working. Okay, I'm going to come around. If you need help, got questions on something,